problem on the put a practice problem on the screen. Okay. Practice problem up on the screen. Okay. Oh, God. I'm gonna have to ask you to stop drawing on the screen, or you will be. Yo, Vishnu, do you know how to disable the whiteboard for other people? Or search up. Okay. Yeah, can you do that real quick? You already got caught. Where's this thing?
Hi, everyone. Before we begin the class, can we just take a quick class photo? So can everyone please turn your camera on and we'll just take a quick class photo. So you can like stop sharing the whiteboard for now.
All right. Okay, I'm just
Figure
gonna
this out.
figure out how
I'll just
to.
try to figure out how to disable the
Yeah.
annotations.
So,
All right, we still have a few people who have not turned their cameras on yet. If you don't have a camera, try to like join on an iPad or something or a phone, so then that should have a camera.
Wait, could you like stop for a second? I'll just grab a light.
All right. Well, I think we should be good now. So thank you, everybody. We're done taking the class photo. You can
I
reshare.
think my cam was off.
What?
My camera was off.
No, I think your camera was on.
Really?
No, yeah, it was not. It was off. Okay, that means okay, we have to take another one. Just everybody, you can just keep your cameras on during the class. It'll help the engagement for our teachers. Okay, wait, did you figure out how to fix the whiteboard?
yeah, I think I did.
All right. All right, let's go on to the lecture then.
Okay. Sick. Okay, so let's just start off with a quick practice problem dealing with geometry. Okay, we have A and B. All right, let's do something. 1 second. We're gonna do this. So let's say we have a square. Okay, it's gonna be a square with side lengths 2. All right, and so A, B. So what's gonna be the answer if A is the area of the square and B is the perimeter? Okay, put it in chat. Okay. I see some people saying B. I see some people saying C. Okay. So the correct answer here would be B because the perimeter, you should, as we all know, sorry, not that. So the perimeter, I'm going to put it here, is the sum of all the side lengths. Okay, and this goes for any shape. This goes for any shape that is closed. It goes for a square. It can go for a triangle. It can go for like, let's say a pentagon. So the perimeter is just the sum of all the side lengths. It doesn't matter if they're different lengths. It doesn't matter if they're the same length. It's just going to be you add up all of them. But area is a little trickier, in my opinion. It's not too bad, but area is the slightly trickier one. Area is going to be the length times the width, or sometimes you'll hear it as height. Width, I'll put width, height, or breadth. Area is the length times the width, height, or breadth. So what this really means is, let's take the square example. So now a square, as we all know, has all the sides are the same length. So this would be 2, 2, and 2. So in this case, let's just choose one of these to be length. So I want to choose this one right here. This is going to be L length. And so if this is L or length, the one that's parallel to it, this cannot be L. It cannot be width or height. This is also going to be L. And so in this case, we have to choose the adjacent side or the other side. This is going to be our width. So that gives breadth is just another way of saying like width or height. It's not all too common. It's just when you hear someone say that, it's just width. So in this case, our area of the square is going to be 2 times 2. 2 times 2. And that is 4. So what is the sum of all of our sides going to be? So we have 1, 2, 3, 4. We have 2 plus 2 plus 2 plus 2. So what is 2 plus 2 plus 2? For 2 plus 2 plus 2 plus 2, that's going to be 8. Or, as some of you put in the chat, 2 times 4. That's also 8. So in this case, because 8 is bigger than 4, our perimeter of the square is going to be bigger than the area. So that means B is our answer. All right. So let me just I'm going to throw up another practice problem for you guys. So this time we're going to do a triangle. Okay, let's make this 3 and this gonna be 4. All right, so just I want you to put into chat what the area is and what the perimeter is. Okay, I see 6. See 6. Head perimeter is 12. Okay, so I see a lot of you put area is 6, and that is correct. But it's like I said before, area is a length times width, but that is only applicable to rectangles. So anything that has 4 sides and four two sets of parallel sides. So a triangle is going to be the area is equal to 1/2 times the length times the width. Because if you think about it really, a triangle is just what? It's gonna be half of a square. So this would be 4 and 3. So it would just be like you do a rectangle where you do 4 times 3. But really, all we want is we want the area of this part. So you multiply it by 1/2 to get half of the whole thing. And then to get our perimeter, we're not given what this line is. Can anyone tell me what this part of a triangle is called?
The hypotenuse.
Yep, that is correct. And do you know how to calculate the length of the hypotenuse?
A squared plus B squared equals C squared.
Yep, that is part of it actually. So what he said was a squared plus b squared equals c squared. It's called the Pythagorean theorem. I'll write it up there. And this tells us how to find the length of the hypotenuse because we're not given this length. And a lot of the time, you won't be given this length if you're given these two, or sometimes you'll be given one of the lengths and the hypotenuse's length. So basically what a squared plus b squared plus c squared means is a and b are these two sides of a triangle. So let's call this a and this b. And the hypotenuse is called c. So this theorem tells us that a squared plus b squared is equal to c squared. So let's try that. So 4 squared plus 3 squared is equal to 16 plus 9 is 25. So what does that make c? So let's put equals c squared. So what does that make c? Yep, c is
5.
5. And then our perimeter would then be 3 plus 4 plus 5. And that is 12, as I saw a lot of you put in chat. So great job. And the Pythagorean theorem is something you guys should all like write down somewhere or just make sure you study because this is going to be all over the test, especially when you talk it's for geometry. It's just something that's really easy to like trip you up. And so now let's move on to another. I'm just gonna throw another practice problem up there. It's gonna be another triangle, and I want you guys to tell me the area and perimeter of this triangle. Let's do what if height? Okay, height is 7. Okay, I'm gonna do this practice problem. So I'm gonna put in chat. So height 7 and length 2. So this time I want you to do 3 things for me. I want you to find the area, the perimeter, and length of the hypotenuse. Okay, I see a lot of you putting the area as 7, and that would be correct because we have 1/2 times 7 times 2 is equal to 7. So you're right on the area. And can I get some answers for what you think the hypotenuse and perimeter are? And no need to simplify anything, just leave it as is. Okay, I see square root of 51. I see square root of 53. Okay, perimeter 14. All right, okay. Okay, perfect. So I saw a lot of square root of 53 in it. So let's just go through the a squared plus b squared equals c squared process. We got 2 squared plus 7 squared equals 4 plus 49 equals 53. And as a lot of you said, because c squared is equal to 53, we're going to do the square root of both sides. And in case you don't know, a square root essentially just takes away, like, it's just going to be undoing the squared. So we would get c equals square root of 53. And we can write that right here. So what would that make our perimeter now that we know the length of the hypotenuse is square root of 53? Okay, not seeing a lot of answers in chat, but that's perfectly fine because the square root might scare you a bit, but I just want you to treat it as a regular number that you don't really have to like add into anything. Because in this case, it would be 7 plus 2 would be 9, and we would just add that to square root of 53. Now, technically, this does equal an answer, but you would need a calculator to do that, and you don't get a calculator on UMTYMP test. And I see someone put 7.28. I think that's square root of 53, but like I said, on the UMTYMP test, you don't get a calculator, so you wouldn't be able to simplify that. And also, just in general, in math, you don't have to simplify these kinds of square roots. You can, it's either you leave them as is or you find a way to like break it down to a smaller square root, which we can't in this case because it's a prime number. All right, now let's do something that looks like this. It's gonna be a little trickier. Okay, let's do like that, that. Oh, that's not do. This is gonna be this is a parallelogram, so I'll just put it like that. Okay. All right. And so I'm gonna call this length is gonna be 10. This is gonna be 4. This will be 3. That's not 3. That would be now I'm gonna make this would be the square root of 116. So I want you to tell me what the area is and perimeter. Right? I'm seeing a lot of 40s for the area, and great job. So because it's a parallelogram, it has the same exact rules as any rectangle would, because as you know, a rectangle is it's a type of parallelogram. So in this case, it would simply be 10 times 4, or length times height. I'm going to say height here because 4 is not the width, it's the height. And for the And when you do area in a parallelogram, they'll give you this number a lot of the times, and it trips up a lot of people because this they might think that this you just multiply, oh, you multiply this side and this side like you would do for a square. But in this case, you wouldn't because this is the height and this is simply just another side length. And also, you couldn't do this number times this number because this is not like what we'd call the base. Because when you do area, you want it to be like the kind of the base of the shape, right? Like this is like the bottom or this is the top. Like if you were to set it down flat, this would be the thing. Like in 3D space, this would be flat on the ground, whereas this wouldn't really be flat on the ground. And so the perimeter for this one is actually really simple because you would just know that this is also 10 because it says here that they're parallel and it's a parallelogram. So two sides are equal, two sides are equal. This would also be square root of 116. And you just add that up, you get 20 plus square root of 116 plus square root of 116. And this also simplifies down to 20 plus 2 square root 116. And this 2 square root of 116 just is nothing other than 2 times square root of 116. So don't let that trip you up either. All right. So now I think let's move on to slightly bigger shape. This I'm not gonna give you any help on this one. I just want you guys to try to figure it out. This is gonna be a hexagon. And as you should all know on the UMTYMP test, I'll put it in chat so you guys can all see. The images are never like drawn to scale. So just because one side length might look the same length as another one does not necessarily mean they are, or just because one doesn't look the same length doesn't mean that they aren't the same length. So in this case, I know this might look a little funky, but assume that this is an equilateral hexagon or all sides are the same. So I'll just write it up here. So it's an equilateral hexagon. And sometimes we'll also mark it with these dashes or ticks. And what essentially these ticks mean is that if there's the same number of ticks on each side, they're the same length. Let me know if there's any confusion about that one, but this is just simple marking. So I'm going to call this side length 3. In any of you, and I'll call this height right here. We'll call it 5. And can you guys tell me the area, the perimeter of this hexagon? I'm seeing a lot of 18s for the perimeter, and that is correct because a hexagon has 6 sides. Multiplied by the side length is 3. So we have 18, correct. And I'm just going to throw this up there for the area. I know this might be a little tricky for the area. The area of a hexagon doesn't usually come up on tests unless they give you like this kind of base area, which I didn't give it to you. So the area of a hexagon is going to be 3 times square root 3 over 2 times the side length squared. So this like never comes up, and I don't think you should worry too much about the area of this, but just so it's just for your reference, I'm going to put it up here. It's going to be 3 times the square root of 3 over 2 times side length squared. So forget about the area. I don't need you guys to calculate that because, like I said, they're not gonna, unless they tell you what this base is, in which case it would just be 2 trapezoids. I'll tell you how to do 2 trapezoids in just a minute. So let's just apply this formula and see what we get. So we have 3 squared root 3 over 2 times the side length squared. Our side length squared is going to be 3. So we have 3 square root 3 over 2 times 9. And this is going to equal 27 square root 3 over 2. So, like I said, don't worry too much about the area. If you want, I would maybe just write this down, but it doesn't really matter. It's not going to show up. But you know what will show up is this. It's going to be the area of a trapezoid. Can anyone tell me how to find the area of a trapezoid?
Half half B1 plus B2 times height.
Okay, that is correct. So what he said was, I'll just write it up so you guys can all see it. What he said was 1/2 times B1 plus B2 times H. So what this essentially just means is I'm going to put it up here. This is going to be B1 and this is going to be B2. And right here, this is going to be H. So B1 and B2, like we were working before, like when I said L times W is the area. So another word for length is also just base, like I also said another time. So in this case, we have two bases because it is a trapezoid and they are not the same. They're not the same length. So what we're essentially doing is we are taking the average of both of these lengths to get a not what like just one number. So that is what these two are. These two, this is one, base two. So what you want to do is add them, divide them by 2 to find the average of them, and multiply by the height, and that gives you the area of our trapezoid. So let's just do some practice with that. I'll leave the formula up for you, and I'll just label this one. So let's say that this base is like 5, and this is 6. We'll put the height as 9. And as you can see here, because the images are not to scale, the height looks a lot smaller than everything else. So you guys can try your hand at that and see how it goes. Okay, I'm seeing a lot of different answers in chat. That's that's good. That means I can teach you. All right, so let's just start off by applying this formula we know. I'm going to write it again, like in a easier way to see. All right, so what is our base 1? So really it doesn't matter because this is addition, so I can just choose whatever. I'm going to choose 5 as my base 1. 5 plus 6 over 2. What's that going to equal? That's going to be 11 over 2. And I could make this 5.5, but I'm not going to do that right now because I still have to multiply by h. So let's multiply by our h, which is going to be 9. And what is 9 times 11? What's 9 times 11 over 2? This is going to be 99 over 2. Now I can simplify this. So what is 2 divided by 99 going to be? Well, if you said it in chat already, it's going to be, let's see, 4. 9 0.5. 49.5. So our area for this is going to be 49.5. And does anyone want to try to get the perimeter of this? Okay, I see 29 in for the perimeter. Okay. All right, so I'll just show you how to do the perimeter, and with that, I'll also show you a different way to find the area of a trapezoid in case you ever blank out on the formula, because I know a formula is sometimes hard to remember. So what we'll do is we'll move this height over because the height doesn't change wherever it is in a trapezoid like this. So what we'll do is we have 9 here, and we also have 9 here. I'm just gonna mark it twice. So now that I did that, what do we have here? We have 2 triangles and a rectangle, right? We have a rectangle that has this is 5, and because we blocked it off on this side length here is also going to be 5. And what's the side length? What's the height of this rectangle going to be? This is this rectangle. Yep, the height of this rectangle is going to be 9 just because the height of the trapezoid is also 9. So then, can anyone tell me what these ones will, what these side lengths will be? And they are equal. If this right here is 5, what are these? What are these?
0.5.
Right? Okay, correct. These are going to be 0.5. So I'll just draw another triangle here. This is going to be 0.5, and what's the height going to be? It's going to be 9. All right, so then what we can simply do in this case is, since we have this rectangle and we have 2 of these, I'll just draw another one of these. They're not the same, but they're the same. They're the same type. So then another easy way we can do to find the area of this whole trapezoid without this equation would just be, what is it? Find the area of this, find the area of this, find the area of this, and add them together. So let's just do it real quick. What is the area of this rectangle going to be? All right, it's going to be 45 because 9 times 5 is 45. And what's the area of this triangle going to be?
4.5.
It's actually not, this triangle is actually not going to be 4.5. It's going to be 2.25 because you have to do 1/2 times base times height. So 0.5 times 9 is 4.5. Multiply that by 1/2 is going to be 2.25. And it's because this is the same one. This is also going to be 2.25. And we can just add all of these up, and we would get 45 plus 2.25
Yeah.
2.25 is equal to 49.5. So that's just a neat trick in case you forget this formula. You can always just divide it up into two triangles and 1 rectangle, just like it is. And because we've already got here, we can actually find the perimeter using Pythagorean's theorem to define what these side lengths are. And so then let's try that. We'd have 9 squared plus 0.5 squared. So that's going to be 81 plus 0.25. Okay, that's a little more a scary number than I expected it to be, so I'm not going to go all the way. Okay, I see Grayson just asked if isn't there like Pythagorean triplets? And that's actually a good question because there actually are. And basically what he's saying is there are special triangles, like a 3, 4, 5 triangle that you should know, because these are just not, because if you do 3 squared is 9 plus 4 squared is 2, 4 squared is 16, 16 plus 5 is 25, square root of that is 5. So there's 3, 4, 5 triangles. That's actually that's a neat way to just, if you're given, say, just 3 and 5, you know that this is 4 automatically. Or if you're given 3 and 4, you know that it's 5 automatically. I see someone put 7, 24, and 25 is also one. That I believe is also one. Let me just put it up here. 7, 25, 24. So basically a Pythagorean triplet is just where you have 3 whole numbers, whole integers. 1 second. So then in this case, and I see a lot more, I see 6, 8, 100. Yep, that's all 10. That's how many are there? I believe it's an infinite number, but I think the biggest one you should know is simply just the 3, 4, 5 triangle, or and the 6, 8, 10. But they don't really serve a purpose on this specific exam other than just being like an easy way to spot them. So I wouldn't worry too much about memorizing a lot of them. Just know how to do the Pythagorean theorem. All right. So now we're gonna move on to the next shape. Let's see if you guys know how to find the area of this. Wait, that's wrong. Does anyone know how would you find the area or perimeter of this shape? Okay.
Pi r squared.
All right. That's correct for area. Area is going to be pi r squared. Can anyone tell me what the perimeter of a circle is called?
Yeah.
2 pi d.
All right.
2 pi r. 2 pi r.
Yeah, 2 pi r is right. And does anyone know what the perimeter is actually called? It has a special name for a circle.
Circumference.
Circumference.
Yep, it is a circumference. I'll type it in chat. Perimeter of a circle is circumference. So on the UMTYMP test, they will be asking you for the circumference of a circle. They will never ask you for the perimeter of a circle. So if you ever hear circumference, know it's for a circle, and it's just asking for the perimeter or the length of this line. So like I said, the area would be pi r squared, and the circumference is going to be 2 pi r or pi d. You'll see 2 pi r is more common.
I don't
So,
care.
can anyone tell me what r is? Put in the chat if you know.
Radius.
All right. Yep.
Radius.
R is the radius. And what the radius is it's going to be the length of, it's not the length actually, it's the distance of every point. Disappeared. I think my whiteboard just disappeared. All right, let me just throw that circle there. All right. Just all right, so we have radius is the distance of every point.
From the center.
Yes, the distance of every point on the circle from the center. It got deleted. Wait 1 second. Sorry about that. And I thought someone asked about radians. So radians are not, I don't believe, are going to be on your test because radians are just another way of, so you know how angles have like degrees, 60 degrees, 30 degrees, 40 degrees? Radians are just another way of saying what that degree length is. And that's not going to be on the UMTM test, so I will not be talking about those today. Like, for example, I'll say an example. 90 degrees would be equal to pi over 2 radians. So that's not going to be on this test, so I'm not going to cover that right now. But that delves into a lot of other things like trigonometry, and right now we're working on geometry. It's called the unit circle, but yeah, that's what it's going to be. All right. And then, can anyone tell me what the diameter is? Put it in the chat, please. right? I see double the radius.
Double the radius.
Yeah. So diameter is gonna be double the radius, but what it also is the line drawn between two opposite points on a circle that that includes the center. So I'll just draw you an example. So in this case, I'll put the center right here. So our radius would be this. It's going to be in red. So this length right here is our radius. And then our diameter will be something like that. Assume they're straight. And so this is going to be R. This will be R. And this is D. And so, like we said before, area is just pi R squared. And pi, I'm sure some of you know what it is. It's just a really long number that is like 2.14159 like 268, I think. Dot dot dot. So in math, we never really use this actual number. So don't mem if you want to memorize it, I'm sure there's some awards. So the thing is, like Grayson said, we can simply just call pi as it is. Like you would never call the number 4.0000. You would just call it 4. So we treat pi the same way, like we would treat any other number. We just call it pi, pi. And so let's say our radius in this case was 3. All right, so what would our area be if our radius is 3? Okay, I see 6 pi.
28.2.
So, okay, 6 pi, 6 pi. All right. So I'm seeing a lot of 6 pi's in the chat.
28.2.
So what we're gonna do is, so we have our radius, we're gonna square it. So pi times our radius squared. And so when you square a number, it's the number times itself, right? Like a squared is equal to a times a, right? So in this case, 3 times 3 is 9. So our area would be 9 pi. All right, and I'm not going to simplify it any further. 9 pi is the simplest form you can get. So in this case, our area is 9 pi, and leave it at that. And it's not going to be 6 pi. And never try to simplify it down. You could try doing like 3.14 times 9, but 9 pi is the most exact version of your area. So just never expand pi. Unless the question explicitly asks you to do 3.14, but me personally, I've never expanded pi unless it's for a science class, in which case in physics, where they would want you to do 3.14 or something. And so then let's say, going back to this example, if our radius is 3, what would our circumference be? You put it in the chat. Okay, 6 pi, 9 pi. All right, I'm seeing some 6 pi's and 9 pi's. See 9 pi. All right, so our radius, I know it got deleted, but that's gonna our circumference, sorry. It's gonna be 2 pi r. So we have 2 times pi times 3. This is what our circumference is equal to. 6 pi. And I know I wrote down before it is also equal to pi d. And that's simply because 2r is equal to d, right? So d is equal to 2r. So when you see 2 pi r, you see pi d, they mean the same thing simply because 2r is equal to d. 2 pi r is the more common variant of this formula you'll see. I don't think I've ever seen a question say 2 pi d, but you can do either, whichever one's easier for you to think. So know this. This is the area of a circle, pi r squared, and this is the diameter, the circumference of a circle. I'm just going to throw another practice problem up there for you guys. And I'm seeing a lot of like numbers in the chat for these answers. So anything that doesn't have pi in it will technically be wrong because that is not the most exact version of the number you can get. So always just leave it as pi, never expand pi. I'll draw one problem up here. Okay, let's call this 5. So call this 12. All right. I want you guys to give me the area and the circumference. Right? So I'm gonna start off with the circumference on this one. So we know that circumference is 2 pi r or pi d. In this case, this line we're given is d, so we have pi times d is going to be equal to 12 pi. So our circumference is 12 pi. There's no need to double this one or anything because this length is the whole diameter, aka 2r. And then for our area, in this case, we have to divide this by 2 to get our radius. So we have radius is equal to 12 over 2 is equal to 6. So our area is equal to 6 squared times pi. Let's take pi is equal to 36 pi. Perfect. So, all right. And pi, so everyone understand that? What if it's a semicircle? Okay, that's a great question. Okay, I'll just draw a semicircle up there for you. So if it's a semicircle, you know how when we did triangles, they were half of a entire square. So that formula was half pH because it was half of like rectangle. It would be the same thing for a semicircle. So let's call this radius. We'll call this radius 2. So any any of your answers you get, you would just divide that by 2. So in this case, pi r squared over a 2, pi r squared over a 2, or 2 pi r over 2. That would be your answer. It's if it's a semicircle, if it's a quarter circle, if it's a third circle, that's all that changes. All you do is just divide by the how much ever it is. That's a really good question. Thank you for asking. And I think earlier I saw some questions about arc length. I don't recall if arc length is on the test per se, but I will just put up an example. So let's just imagine that this is like a piece of a whole circle. Let's call this right here 45 degrees. Actually, wait, I'll come back to arc length because I have to cover angles anyway, so we can just do that at the same time. So can anyone define like what an angle is in the chat, if you can, please? Angle is a degree. So I'm not entirely sure like what like the textbook definition of an angle is, but I would just remember angle is like kind of like the space between two lines, if that makes sense. Kind of like this is one line and this is one line. All right, I see someone put a whole definition in. Geometric. Okay, that's really confusing. So I would just kind of like the space between two lines, like how far apart are these two lines is kind of what an angle is. So let's like examples of angles would be this is like 60 degrees. Okay, so I'm just gonna go through angles pretty fast. Does anyone know the different types of angles? There's three main ones.
Acute
All right, I heard
and
acute.
90. Obtuse.
All right, I hear obtuse.
Right angle.
Right.
And a right. All right, great. So basically, these are just different names for different angles.
Straight angle.
Oh, and a straight angle. Yep. Can't forget
Reflex
that one.
angle.
All right. So the main ones you have to know are just acute, obtuse, and right. So an acute angle is just any angle less than 90 degrees. Okay, and an obtuse angle is any angle greater than 90 degrees. And a right is angle equal to 90 degrees. All right, so I'll just draw pictures. So normally what they would look like is kind of you have something that looks like that would be an acute, like 60. This is going to be a right. A right always is marked by a triangle like this. It's never marked with sorry, a square like this. All right, yeah, I will speed it up to practice test. We'll start that in 2 minutes. And then obtuse is this, say like 120. So I'm sorry, class, we weren't able to get to all of angles, but we did cover like parallel lines. Not actually, we didn't cover parallel lines, but these are what they are, different angle types are. And we have to start the practice test soon, so I will hand that over to, I think it's Vishnu. You do that?
Uh, so if you guys want to go towards the Google Classroom,
Yeah,
or
everyone navigate to the Google Classroom.
Google Classroom, and then we can start just open up the Google Classroom, and then there should be a PDF for the mock test.
Yeah, and I'll share a timer if everyone wants.
What is the class code?
The class code is, I think it's, do you guys want the share screen?
Yeah, I can't share. Just make me host real quick.
All right. Made you co-host, see if you can.
Yeah. All right, can you guys see it?
We can see it.
Oh, yeah, we can see it.
All right.
All right. For question one, the answer would be D here because it really depends on the value of x. So, like for example, if x was between 0 and 1, where is it? The answer option A would be bigger. But if x was equal to 1, where is it? Both of them would be equal. But the thing is, if x was greater than 1, where is it? Quantity B would be bigger. So we really don't know until where is it? They goes the value.
All right. For number 2, the symmetries in circles are significantly bigger because there's in a square right here. it's just through like that in a circle, it's almost infinite. So it's going to be B for 2.
Okay. For 3, this would be answer option D. Where is it? For this to be solved, we need A to be defined. So if A is greater than 0, where is it? Since we don't really know like the value of A, where is it? We can't really determine the answer. So
All right, for 4, it's going to be A. Because D and A or D is greater than A right here. And they're both divided by the same number, C. So it's just going to be A.
for number 5, I understand if some of you got this up, you were kind of lost because didn't really talk about an Alex in this question, so that's our bad. We'll make sure to not do that on the next test. But if assuming Alex was Daniel, where is it? It would be 5 squared plus 3 squared equals the square root of 34, which is equal to 5.83, which would be B.
All right, for 6, it's going to be A. Let's see. For A, it's going to be an equilateral triangle like that with 6 on all sides, and here it's going to be a right triangle like that. 6, 3. And just by looking at it, you can tell. But if you remember the 1/2 base times height, you're going to get 9 because 6 times 3. Hold up. Yeah, 6 times 3 is 18. And it's going to be 9. And for the equilateral triangle, it's going to be 15.6 because it's just going to be bigger. Just remember that.
Okay. For question 7, where is it? Okay, since the diameter is equal to 4 inches, so then the radius would be 2 inches. And remember, recall from Aditya's lecture, pi r squared is equal to the area. So if we plug in 2 as the radius, we get pi parentheses 2 parentheses squared equals 4 pi, which is about 12.57 square inches. So in this case, the area of the cookie would be slightly bigger than option B, so it would be A in this case.
All right, so you should remember that the sum of all quadrilaterals, the interior angles, are always 360. So a rectangle has 4 sides, a quadrilateral, and trapezoid also has 4 sides. So both have 360 degrees. So it's going to be C.
For 9, the number of faces on the cube is 6, and the number of sides on the square is 4, so A would be bigger here.
All right, so 10, this is 90. And a complementary angle is just like the relationship between two angles summing to 90. So it's not a fixed value, so you can't really determine that. Let's see.
Are we on 12 or 11?
11.
Okay. For 11. Okay. Okay. The sum of all angles in a triangle is 180 degrees. So if 2 angles sum up to 40 degrees, the remaining angle has to be 140 degrees. Actually, wait. Yes. So 140 would be greater than 130.
All right, for 12. Here. So the time it took to fly is not given. It just says the distance. And 8 hours, like you can't, there's no relationship, so it's going to be D. Cannot determine.
Okay, for 13, the perimeter is equal to 4 miles. So each side is about 1 mile, which is about 5,280 feet. So quantity A would be 5,280 feet, and quantity B is 5,270 feet. So in this case, it would be A.
All right, for 14, the area of a circle, as you guys should know, is just pi r squared. And B is also pi r squared, so the answer is C.
Okay. 15. The answer option here would be C because
Excuse me,
so
no mean to interrupt. Can I like leave?
yeah,
Thank you.
just feel free to email us if you feel if you have any question on any of the tests, questions
Like
on the
which
test.
email, like the MET Excellence email, or like to separate?
Uh, I will post mine and R's email on the Google Classroom, so you can just email us like individually if you want
Okay,
to.
thank you.
Okay, so continuing on, the sum of all angles in a triangle is equal to 180 degrees, and the sum of all angles in a square is 360. So 360 divided by 2 is equal to 180. So therefore, A and B are equal.
All right, so for 16, these are gonna vary depending on the value of R. So when R is equal to 2, they're equal. Wait a second. Yeah. When R is equal to 2, they're equal. And if R equals 5, then the area is bigger. And for example, if R equals 1, then the circumference is bigger. So it's going to be D.
Fair. 17, the answer option would be B, because for a square in a circle with a radius that is equal to 4, diagonal of the square equals the diameter of 8 inches. So if the diagonal equals 8, then the sides will be 4 square root 2. So what the hell? Okay. I don't know why I'm doing. Okay. Okay. So in this case, actually, it would be A. But just move on.
Okay, for 18, 0 can be divided by both numbers, so each of them have 1. 18 can be divided by 3. And then, let's see, 7, 5, 6 can be divided by both, and then 4 can be divided by. So in this case, it would be C.
For 19. Uh, okay. In any right triangle, the hypotenuse is always the longest side. So it is always greater than one leg.
All right, here. Are we on 20 or are we on 21?
Around 20.
All right, 20. So A is, right here, A is negative. So let's say like a negative number like -1 raised to 2. This would always be positive. Your negative number raised to 9, or an odd number, would always be negative. So here A is.
Okay. Where is it? Question 21. Okay. So the answer option here would be A, since where is it? 10 to the 24 is equal to 2 to the power of 10. And the number of factors would be 11. So it would be A.
All right. 22, the answer is going to be D because, say, X is 41. This is less, A is less than B, but if it could be like 100, like 3 times 100. That is greater than 5, so the answer is D.
Okay, 23. Can't see this properly. Okay, 23. It would be B. What? Okay. Since the quantity of the slope of A is -4/3, quantity of B is, where is it? Is also -4/3. Where is it? The answer option would be B.
All right. So composite numbers less than 6, there's only 1 for the composite number. Number of prime numbers is 1, no, it's like 2, 3, and 5. So this would be B.
What portion are we on?
25.
Okay. These are actually like the same. Okay. Okay. The diameter of a circle is from one end to one end, and then the radius is from the center to the where is it? To one of the edges. So if you divide the diameter by 2, it's just the radius, so it would be the same. So it would be C.
All right. Circle has area 4 pi, so this is the area. That's the formula for area. So 1 second. How am I doing? That's R. So 4 pi is R. Then the circumference is 2 pi R, which is 22. So the answer is B.
27. Okay. The answer option here would be B. Where is it? With the diameter equals 6. So the radius would be 3. So the circumference of the circle would be 2 pi r, which would be 6 pi. And then for the area, it would be pi r squared. So it would be 9 pi. So here it would be, what is it? The area of the circle. So B.
All right, 28. The sum of angles in a triangle is always going to be 180 degrees. Then a rectangle, again, a rectangle is a quadrilateral, and they always have 360 degrees. So it's going to be B.
Okay, 29. Oh, an angle formed by two perpendicular. Okay. Two perpendicular lines always form a 90-degree angle, and a acute angle is less than 90 degrees from Aditya's what is it definition of an acute angle. So here, where is it? The angle from two perpendicular lines intersecting would be correct. So it would be quantity A. That would be bigger.
For 30, an acute angle is always going to be less than 90 degrees. So it could be, let's say, 89 plus 89. It's always going to be less than 180 degrees. So this one is B.
Okay, 31. What? I'm pretty sure we already had this question. So this one would just be A. Okay.
All right. 32 will be B. Because, let's see, the volume of a cylinder is going to be, and the surface area is pi r squared, and then h. Surface area is just going to be bigger.
Okay. 33. Answer option A would be bigger. Where is it? Because an octagon, where is it with the eights? An octagon since times with okay. 8 times 3 is equal to 24, and hexagon times 4 is equal to 24. So here would be C.
All right, for 34, it's going to be D, because we are not given if x is positive or negative. Let's say x is negative 9, and here it's going to be 9, and this is going to be negative 9. But if x is like, say, 2, it's going to be 2, and this is also going to be 2. So it's D.
Oh, for this one. Okay, for this one, when you set for the y-intercept, when you put 0, no, set x equal to 0. So here the y-intercept would be -4. And then here, where is it? We set to find the x-intercept when you set y equal to 0. And if we solve for that, where is it? We should be left with 2.4. which is greater than -4. So here, quantity B would be bigger.
All right, this one is kind of a trick question. So here it says there are 30 times more associates. So that means this is 30 over 1. That's clearly bigger than 1 over 30. So
Uh, oh, okay. Okay. For this one, it's for finding the area of a square, it would be side length times side length, which would be like, for example, like if we use the variable s for the side length, it would be s squared. And perimeter, using the same variable of s, it would equal 4s. So without knowing s, where is it? The answer can't really be determined, so it would be D.
all right, here the same triangles are being scaled, but 2.4 is greater than 2/3, so it's going to be A.
Okay. Here it would be, where is it? It would be equivalent, or answer option C, because the product's from -7 to 3, which includes 0, so the product equals 0. Where is it? Since if we remember, where's the product is multiply. And then the product from -3 to 7, which also includes 0. So the product would also be 0. So the answer option would be C, because they're both equal to 0.
All right, for 40, could rewrite this as 0.04 times 3, and here 0.03 times 4. Both of these equal 0.12, so the answer will be C.
Okay, for 41. Okay, this one, uh, we really can't find out since we don't really know that we don't know the number for x or y. So this one would be, so we can't really know. We need more information.
All right, here 40% of 80 can be rewritten as this. It's just equals 32. Here, this is 240 over 5. That equals 48, if I'm not wrong. Wait, no, I'm wrong with that. 28. So this one will be B.
Okay, so for question 43, okay, for
Wait, no, wait,
one,
let me correct myself. It is 48. So it's A.
okay, for number 43, where is it? For quantity A here, where is it? We can recall 1/3 is equal to 0.33 repeating. So the 69th term of the decimal point of 1/3 would also be 3. So they would be equal.
Okay. So the sum of the interior angles of an octagon is going to be 1080, and pentagon is 540. If a shape has more sides, then it's always going to have more angles. Like the sum of the interior angles is always going to be greater. So here it's going to be A.
For 45, this is again D, because we don't have enough information about the length or width of the rectangles, so we can't really find out either one.
All right, 46. A diamond is a quadrilateral, so this is 360 degrees. And there's always just 360 degrees in a circle, so this is C. The circle is an exception to the side rule, by the way.
47 is kind of a bad question. Uh, um, well, there never is an angle formed between two parallel lines when they intersect, because parallel lines never intersect. And then x squared This just makes no sense. It's a bad question. I'm sorry.
All right. So the mean of the scores, these, if you did the calculation, it should be around 87.2. And the median is, you could just put into order. And you do that, you could just cross out. It's 86. So A is bigger.
Okay, question 49. The smallest positive integer and the smallest positive prime integer. The smallest positive integer is 1, and the smallest positive prime number is 2. So, or is it quantity B would be bigger?
All right, you all should know that a penny is 1 cent.
Okay, it's okay if you
A
don't know
nickel.
what the value of a nickel is. I don't know either.
Yeah, I mean, you'll find out one day. It's 5 cents, so it's clearly B here.
Okay.
Any
If you guys have any more
questions?
questions, I will publish a homework later, or is it later today or tomorrow? So if you guys want to do that, you can. And then I will post my email, my school email. What is it? So you guys can like email me if you have any questions. And that's it for today.